Hello, I'm Nick Hodges, Senior Software Engineer at Veeva Systems, and today I'm here at CodeRage 9 to talk to you about enumeration, enumerators, and the IEnumerable of T interface. Here's our agenda today. We'll talk enumerators, how they work, how you can get your classes to work with the for in statement. Multiple enumerators per class. We'll talk about how to get your class to expose different enumerators, because generally speaking, a class can only have one enumerator. We'll then look at the IEnumerator pattern, and then we'll move on to IEnumerable of T from the Spring for Delphi framework. We'll talk about how you can use that to expose list properties, and then we'll just summarize and take questions at the end. I don't have a lot of slides, so let's go straight to the code. Enumerators are basically a simple class that's embedded inside of another class that enables you to iterate or enumerate actually over a given set of things inside that class. It is the construct that allows your class to be used with the for in statement. So here we have a very simple class called for in demo. It has as its property a string, and that thing is the string is the thing we'll actually be iterating over. The simple call here to get enumerator is what is required by the compiler in order to use a class in the for in statement. This get enumerator returns an instance of T for in demo class enumerator, which is this class right here, and I'll talk about that in a sec. Basically, it is a class that conforms to a specific pattern that is recognized by the compiler as an enumerator. Here is the enumerator class, T for in demo class enumerator, and in order to be an enumerator, it must do three things. It must provide a current property, it must provide a function called moveNext that returns true if you can move to the next item and false if you cannot. The current item, by the way, tells you what is the existing current item inside of your enumeratable item, and then the function getCurrent is the thing that is the reader for the current property. Now in our case, we're going to be iterating over a string. Now strings are automatically already iteratable, enumeratable inside of the compiler, but we're just going to use this as a demo today. So the implementation of this looks like this. It has a constructor that simply stores the string inside of it and sets the index of that string to 0 as the initial starting point for the string. The moveNext function says I am true if my current index is less than the length of the string, and if I am true, I increment the index of the string to the next position. In other words, I move to the next item inside of the enumeration, and I return true because I can. If, however, we've come to the end of the string, then this will return false and we won't increment the index. And finally, the getCurrentItem simply returns the index item, the character at the index item of the string. Now, down here in the for in demo, this function getEnumerator again returns an instance of T for in demo class enumerator. So when this class gets used inside of a for in construct, the constructor will look for this call to getEnumerator. It will ensure that that getEnumerator call returns a valid enumerator, and it will do so, and it will allow you to enumerate over that class inside of a for in statement, which we do here in the do stuff procedure. So we create an instance of for in demo, passing it hello world. We have a variable car, and so for each car in the for in demo class, we write out the car and a comma after it, and then when we're done we just simply write in at the end. This is a very simple example of building an enumerator into your class so that you can use it with the for in construct. Now we'll go to the DPR file and we will uncomment these two, whoops, and leave these two commented, and we'll do some stuff. We'll actually call the iterator, we'll run the code, and you'll notice that hello world is printed out separated by commas as expected. Each individual character has been enumerated by the enumerator. In this next demonstration, we'll show how you can have more than one enumerator in a given class. The construct, of course, requires a single call to get enumerator, and that means that, strictly speaking, a class can only have one call to get enumerator, and thus only one enumerator. But there's a few tricks we can do in order to give a class more than one enumerator. For instance, I've declared two enumerators here. One is a reverse enumerator, which, if you'll look at notice the implementation, simply starts at the length of the string, i.e. the very end, and then when it moves to the next, it backs itself up through the string. Instead of going from the front end of it to the back, it goes from the back to the front. So you end up with an enumeration that reverses the given string. And here we have another enumerator that descends from the actual first enumerator we just looked at in the previous demo and overrides the getCurrentCharacter function, simply calling the uppercase on the inherited version of the getCurrent function, and that should return an uppercase character for any given character in the enumeration. In order to expose both of these enumerators in a class, we need to create these small proxies. These proxies are classes that have a call to get enumerator that return the proper enumerators that we've decided for them. So we have a T reverse enumerator proxy that calls T4 in demo class reverse enumerator. We have T uppercase enumerator proxy, which when get enumerator is called returns a 4 in demo class uppercase enumerator. And we have a class called T4 in extra enumerators, which descends from our original class from the last demo and simply has two properties on it, which are instances of the proxy classes that we've seen before, and a constructor that A takes the string as it has normally and creates instances of these enumerator proxies as the getters for the properties inside of this extra iterators class. Now what that means is that when you have an instance of T4 in demo extra iterators, you can pass to the for in construct one of these properties that will then return the proxy class, which will then in turn have its own get enumerator call, enabling you to have multiple enumerators on a given class. So the for in demo itself has a regular old front to back, start to finish enumerator built into it, but it also has as properties an enumerator that does uppercase, an enumerator that reverses the string that's passed into the constructor of this class. So when we do stuff here in our function call, procedure call, you'll notice that we have a character variable and a for in extra demo variable of the type containing these two properties, and we simply call for C in the instance of the class as uppercase. This is the thing that's going to be iteratable and enumeratable. And it once again writes out each individual character with a comma in between. And then we do the very same thing for the reversed string. So when we go over to our view source, we will uncomment this method, this procedure. We will run it, and we should see two separate things. One is greetings, all uppercase, and the other one is sknickerig, however you might say that, which is obviously greetings backwards. Thus, that's a technique you can use to have more than one iterator enumerator for each individual class that you might have. For this next demonstration, we'll do something a little interesting in that we'll just tease out a pattern for this and create an interface that based upon that pattern. Now, whenever, I don't know about you, but whenever I hear, oh, this class has to have a get current, a move next, and a current property, I am moved to create an interface based upon that pattern that is required by a specific construct, language construct. And in fact, that's what I've done here. I've created an IEnumerator of T where the get current call returns that type, the current property is of that type, and there's a method called there's a function method called move next that returns Boolean. Now, this is a very similar construct to a declaration in the system unit, but I've done it here for the purpose of illustrating how you can use an interface to create an enumerator as opposed to simply a class. This enables you to expose your enumerators as an interface rather than a class itself. So I've created a string enumerator here, which descends, of course, from t-interfaced object, which does all the reference counting for the interface. And I've declared an IEnumerator of type car. So from there, everything should look very, very familiar. I should keep track of the index and the string internally. I call getCurrent, which returns the current string index. I trap the string, capture the string that's passed in the constructor, and set the index to the beginning of the string. Actually, I set it to 0, and it'll be incremented when upon the first call, just a subtle difference there. And move next, as you notice, will return a result of the index being less than the length of the string. And the result is true if we can increment, if the result is true, then we do increment the string to the first index and each subsequent index. Now, here's a class that exposes that getEnumerator as a interface. Here's the call to getEnumerator, and you notice that it exposes an IEnumerator of car as opposed to an actual class that implements that. Again, this is a internal compiler magic technique that requires a certain pattern be exhibited by the enumerator. And the class can do it, or in this case, our interface can do it. This enables us to, for instance, return various different types of enumerators depending upon settings that you might have inside of your class, as long as that enumerator conforms to the IEnumerator of T pattern described by the interface. So here we have more do interface stuff, which simply creates an instance of T interface enumerator demo, passing in goodbye world as the string, and it iterates over that interface enumerator class, again, once again writing out each character with a comma in between, and it frees the class, of course, when it's done. So here we go for do interface stuff. We'll once again go back to the DPR file, comment out this, comment out that, and uncomment that, and we will get goodbye world with commas in between. Now this pattern enables us to provide another way for providing more than one enumerator for a given class. You might have multiple enumerators internally to the class, say a enumerator factory that might produce an enumerator that implements this interface, allowing you to have more than one enumerator based upon the single call to get enumerator, allowing you to get whichever enumerator you wanted to, as long as that enumerator implemented the IEnumerator of car interface. Okay, so that's cool. We can now create classes that are usable with the for-in language construct. They can enumerate over the elements inside of a given type. In our case, we've been using string, but certainly you could use any kind of list item that allows you to manage a collection of things, such as even an array. But what gets really cool is the notion of being able to control specifically which elements inside of a given list or string or any type of enumerable item can be returned, should be returned. For instance, you may have a list of numbers and you want to produce only those numbers less than 7, or only the even numbers, or only the odd numbers. And you can do that using your own enumerators, but the Spring framework includes a very powerful set of collections that implement an interface called IEnumerable of T that already has built into it any number of given functionalities that allow you to control precisely what is returned from an enumeration, and allows you to even provide your own functions determining what those enumerations are. So in this next demo, we'll take a look at the IEnumerable of T function, or I'm sorry, interface from the Spring framework. So here we have a form that has a bunch of buttons on it, obviously, that do some things with IEnumerable of T. But let's take a look at it first. All of the information, all of the stuff we're going to look at in the next few demos is found in the Spring.Collections class. I'm sorry, unit. Inside of this is a collection of lists and collections, including stacks, queues, lists, collections, demos. Here's iCollection, and they're all interface based and implemented in subsequent units. The thing I want to take a real close look at here is IEnumerable of T, which is found here in the unit. It's a descendant of IEnumerable, but it has a large number of functions attached to it, all of which are implemented by the items and the lists. For instance, here's iList of T, which descends from iCollection of T, which descends from IEnumerable of T, which is an interface of IEnumerable of T. And it has on it and attached to it a large number of methods that provide a powerful way of accessing and looking into and peering inside of, say, a simple list. So what we're going to do is we will go to our form and we'll take a look at how this works. So, for instance, the first one is simply how we set things up. We'll take a look first at how we set things up, So we have a form create event that simply takes a list, an iList of T, calls the T collections class to create a list of T integer string pairs for us. This T integer string pair, the T integer string pair is declared up at the beginning of this unit as a T pair of integer and string. What we do down at the bottom is we pass in the actual integer and then a string representation of that integer. 1, 1, the number 2, the word 2, the number 3, the word 3, as such, up to 10. And it just provides a simple list of items that we can iterate and enumerate over. So for instance, we take the list, we clear the clear call here is to clear the memo out, and we have a pair variable, which is an instance, a variable of T integer string pair. And for each pair in the list, we just simply add the value of the list. Remember, the list is T integer string pair has the T pair has as part of it a key and a value. And in this case, the number is the key and the value is the string for that number. So we simply just iterate over each pair and show out the value. We run it. Oops, I'm sorry, we run this application. Press this, and you'll see it lists out the values 1 to 10. However, if we press this next button, you'll notice that it runs the where enumerable call and produces only the even numbers. Let's take a look and see how that is done. The call to where on the list takes a single predicate. Now, a predicate is an anonymous function that takes a single parameter of the type in question and returns Boolean, true or false. And in this case, it's going to determine is the item to be returned or not. And in our case, it's only going to be returned if the item is 0, i.e. if the mod 2 is equal to, it only returns if it's even, i.e. when the mod 2 call on the key equals 0. So once we have an enumerable of this type, we can then iterate our pair over that enumerable, add them to memos, and we ended up, as you saw, with only the even numbers. IEnumerable has much more, however. Let's continue looking at them. The next one is skip. This one allows you to skip the first 7 items in the list and return everything that occurs after 7. Let's see that in action. Skip enumerable returns only 8, 9, 10. It skips the first 7 items in the list. This item, skip while, will allow you to again pass in a predicate that determines how long you should wait and how many items you should skip before you start producing items. And again, this is a simple demo. You can imagine you could say skip everybody who has a salary less than something like this inside of a collection of employees. But this is a simple example of skip while the predicate returns true. So in this case, we're going to skip everything less than 5. So when we run it, our skip while less than 5 returns all the numbers that are, we skipped all the numbers less than 5, and everything 5 or greater is returned. The take enumerable says take the first 7. In this case, we take those. Take enumerable returns the first 7 items, which allows us again to have complete control over how many items are returned if we want to. The take while, again, takes a predicate that says take them while they're less than 5. Has a predicate here. Take while enumerable less than 5, so it takes them until 5 is returned. All these numbers are the ones less than 5. That's a take while call on IEnumerable of t. We can concat 2 lists together. This temp list call here is called create another list, which returns 11 through 15 and adds 11 through 15 in our list. And we can concat those 2 lists together, enumerate over them, and show 1 through 15 in our window. Concat the 2 lists and we get 1 through 15. So it enables you to take 2 enumerables and put them together into 1 enumerable, as you see here. The next item picks the first out of the list. You can pick the first or the last. Here's the first item, 1. The last one is 10. Very simple call. You simply call that on the list, and it returns a specific pair, and you can show that out. We can say, give me the 4th element. And in this case, it's 0 based, so that'll be 3. Get the 4th, it should say 5th element, I'm sorry. Element at 4, it should give 5. Excuse me, I was backwards there. It's 0 based, so you should get the 5th element at a particular item. You should the IEnumerable T has the smarts to find the minimum and maximum values of a given set of items. So here's the minimum 1, the maximum of 10. And of course, you are able to pass in your own comparer, which will enable you to use these min and max calls yourself. It has a reversed call. Good old reverse. Allows you to return the values in reverse order. Here we go from 10 down to 1. And the real power, however, comes with the notion of actions. You can do an action on each of the items inside of the enumeration, inside of your list. For instance, in our case, we're just simply going to add to memo a formatted string that takes advantage of both the value and the key of our pair. And you'll see the output here. The numeric form of 1 is 1, as you see here. But you can see the power there, of course, of how you can do anything at all you want to each item in the demo. Good old for each is back. And that's the power of IEnumerable. The real power comes in the ability to define anonymous methods to determine which items are exposed and enumerated, and when you have enumerated within the list. For this next demonstration, I'll show you how you can use IEnumerable as a powerful way of exposing lists of items to the users of your class without allowing complete control over the list. So for instance, we have two classes here. One is called tCustomers, which says customers, iList of tCustomer, read fCustomers. And you'll notice that if you stop and think about it here, this exposure of the list itself allows you to do anything to the customer. You can add, subtract, multiply, divide your customers. Well, you can't do all that, but you get the idea. You can do anything to the customer's property because it's exposing a list. If you want to take and still be able to expose your customers in a very powerful way, but limit the ability of your class user to access the customer list itself, you can do something like this. You can create a class that exposes the customers as an IEnumerable, and in order to do that, you'll need to have a reader that is a getCustomer class that returns an instance of iList of tCustomer. Just as a side note, this will not compile. If you try and return the field itself, it will not compile. You need to have a getter, an actual getter that will return the instance of the class. If you want to add customers, you have a function that you expose to add customers to the list. You can create a new customer based upon his name and add it to the list of items. But your customers is exposed as an IEnumerable of tCustomer, which again enables you to limit the input and control of the list, but gives you the full power of IEnumerable of tCustomer to output the list. You can do things like, if you want to later, you can control access to the list by, say, delete customer by name, if you wanted to add that later. So you can use methods on the class itself to control how access to the customer list is granted. But you still are exposing the power of IEnumerable and all of its powerful methods to the consumer of the class. And as such, you can limit access to the iList of customers, but still provide complete access to the output of that customers. That's good encapsulation, and that's a good use of the IEnumerable of tCustomer. So that about wraps it up for code. Let's move on to the summary and questions. So, in summary, enumerators are a powerful and easy to create method for iterating or enumerating over all of your lists and items inside of a specific class. You should be using the for-in construct more, and you should be creating classes that are able to use the for-in construct in order to more easily and cleanly run your lists and whatnot over and iterate over them. IEnumerable of T should be your go-to solution for all lists and collections inside the Spring framework. And the Spring framework can be found at spring4d.org. And that's all I have for us today. You can reach me here, and now it's time for questions.
Enumerate over strings.
And yes, you can. As a matter of fact, that's kind of what the examples in the demonstration did, which was actually enumerate over a string. Strings are highly enumerable, and you can certainly use strings in a for-in statement with the for part being a car and the ins part being a string.
Oh, okay. That question may have came in before the example. That sometimes happens.
Yeah, no problem.
I thought the for-in construct didn't need an explicit free. Is this correct?
Not sure what you mean. It does not need a free if you've it needs a free if you've created something, but the for-in doesn't need an explicit free, no, because it is merely using a class and not either, freeing or terminating a class. So it doesn't need an explicit free itself, but if you create something, you need to free it.
Okay. Good advice.
Yeah.
When did that for first introduced in Delphi? What version?
I think that was 2007, I think.
That sounds right to me.
Yeah, I think that was correct.
So you showed the Spring.collections unit. Does that come as part of Delphi?
It does not. You need to download that as part of the Spring project, and you can get that at www.spring4d.com. That's spring, the number 4, and d.org, .org. Spring4d.org. And that'll take you to the Bitbucket page where you can download, you can pull the source code with Git or download a zip file there.
So it's pointed out that if you create an object, but it's an interfaced object, you don't need to free it in that instance there.
Certainly not, no. If the interfaces are reference counted and they don't need to be explicitly freed.
All right. What's the advantage of exposing the enumerator as a class versus as a string? Not quite sure what that question means.
I think it was probably getting at the demo I gave, and the advantage is it just makes for an easier demo.
Okay, got it.
Yeah, because you can just enumerate over a string normally, but my code enumerated over strings using a class, but that was just for demo purposes.
Okay, yeah. So that's always the trick, making a useful demo that's not.
Yeah.
We heard a question about when generics were introduced in Delphi. What version?
2009 was the first version with generics.
So like we're playing Delphi version trivia for you here.
Yeah, there you go. That one I remember well. So.
Yes, that was a great release. Are old T-string lists enumerator compatible?
Yes, they are. They have old ones. Before there was a for-in statement, obviously are not compatible. But if you're using a version of Delphi that has the for-in language construct, then T-string list is definitely enumeratable.
Yeah, if your old T-string list code got ported to a new version of Delphi, then yeah.
Yes, it will. Yeah.
Let's see. There's some other questions about the specials. So, questions here about your book. Your book goes into Spring 4D, doesn't it?
It does. I cover the collections unit and the container with dependency injection and all that. And I think that's all I cover.
And then if someone else has to do is download the trial and activate the trial, and they can get a free copy of your book right now.
That's true right now, yes. Which is a good deal.
It's a really good deal. Have you thought about downloading the trial and getting a free copy of your book?
I have not. I have the I have both a copy of my book and a copy of Delphi XE7 already.
Oh, you got the full version. Oh, good, good.
Yeah. I actually have a physical copy of my book as well. So.
I do too. I went and got one.
Oh, good for you.
Now I just got to track you down and get you to sign it.
No problem. Will do.
So a question about why you didn't use the odd function
Oh,
in your demo.
I just didn't think to do it that way. I'm sorry. I probably should have, yeah.
That's okay. We'll forgive you. I think so. Bruce is suggesting that you